This is a quick review of setting up a simple physics-based thrust mechanic using Playmaker inside Unity. I'm going to set up a little user control on this rocket. I created this rocket in Cinema 4D, just a real simple mock-up. I'll show you how this model comes in once we export the FBX from Cinema 4D and bring it in. We're going to have to do a little bit of prep, but I kind of kept it intact just to show you. I want to do a little bit of cleanup on it. So I called this Rocket 2. That was the project name, the file name inside Cinema 4D. And so when we export it as an FBX, it inherits that name. When you import it, the FBX from export the FBX from Cinema 4D and bring it into Unity, you end up with this Cinema 4D editor. This is just a null object, empty game object. We can get rid of that. So I'm gonna get rid of that object, and so I have the parent object, and this is really just an empty game object. If we look over here in the inspector, it's just it's got a transform component. There is an animator component which we're not using. We could get rid of that, but I'm just going to leave it there for now. So this is really the equivalent of an empty game object, simple object that just has the transform, and it has all these parts tucked inside of it. So I'll get rid of that empty game object. That's what this is, but we're going to use this as our player object. And so the first thing I want to do is I want to add a rigid body to this, because when I hit play, there's nothing going on with this rocket, and we want to control it with physics. So I'll add a rigid body to it. So I'll select the parent object here, go to physics, rigid body. Now this object's going to fall through space, and just note that there are no colliders on this object. And unless you created some colliders on import, then your object's probably going to not collide with anything if you modeled it from Cinema 4D or another 3D application. So I'm going to fix that really quickly. And there's a couple different ways that we could do this. We could add colliders to the child objects here, but I'm just going to kind of forget about the contents of this for a moment and just set up a quick couple of compound colliders. So I'm just going to add two colliders to the same object. So we'll go to physics, and I'm going to add a simple box collider, because this will be we don't need anything too complex. I do kind of want to emulate the fact that the base is a little bit wider. So with this first collider, I'm going to move the center of it up along Y just a little bit, and I'll make it a little bit wider. So I'm going to change the size of it just a little bit, and I am in perspective here, so I kind of try to flatten that out a little bit, make sure I'm looking like right in the center of it, or pretty close to it. I'm going to make it a little bit taller. Okay, and I'll move it up. So I'm going to create a separate collider for the bottom of the rocket, because it's much wider. Now, if I wanted to be, real particular about this, I could have made a box collider that accommodates the middle of the rocket and something smaller for the top, or I could have even, there's a number of things that we could do here, but I want to keep these colliders really simple, and also demonstrate the fact that we can add multiple colliders to an object. So I'll add a second box collider. So there it is down at the bottom. I have a second box collider component. I'm just going to make this one a bit wider, and I'll make it a little bit taller, and just kind of eyeballing it to make sure that it accommodates these fin objects. I left them pretty big to I like that exaggerated look to it, so I'm just kind of making sure that they pretty much fall within there. Now I'll align this, and I won't spend too much time tweaking this, but you get the idea. So now when we hit play, in this case, the case of this object, now it falls to the ground, and it's kind of sitting on the fins. But there's also kind of emulates this negative space here around the side of the rocket. So again, I could have made these a little bit bigger and have these a little bit closer together, but for the sake of the demo, I think that'll do what we need to do. So we got a rigid body, and we have some colliders, and so now we can get this thing moving. So I'm going to have two separate state machines on this object. The first one, I'll right-click and add an FSM in the Playmaker editor, and this is going to be the thrust mechanic. Now we could combine these. We'll determine what's best as we iterate on these mechanics. But I'll have an idle state, and I'll have a thrust state, And basically for now, I just want to pass this back and forth between idle and thrust based on a mouse down and a mouse up. And I'm going to create just a real simple transition event. Go to my events tab. We could do this in actions, but I like creating my events through this events tab. So I'm just going to make a generic next. I'll add this as a transition and pass it to thrust and loop it back to idle. So we just got a little simple two-state loop here. And the idle state, nothing's going to happen except that we're listening for some input, some user input. So I'll go to my action browser and I'll nest this over here so we can see this a little bit more clearly. And I'm looking for some input, and again, I'm probably going to use a left mouse click here, just so that we can get some immediate feedback here. So I'll do a get mouse button down, and I'm listening for the left mouse, and we'll use this next event as the send event. I'm going to go over to the thrust state, and we'll listen for the get mouse button up, and we'll just use that same left button next. And so now I basically have a little toggle. If I click down, I should pass to the thrust, and when I release the mouse, it should pass back to idle. So I'll test that right now. And you always need to have focus on the game tab when we're testing user input. So if you're clicking over here, one, you can't really debug that state machine, but also you won't be getting the feedback. Same thing with the inspector. But notice that I'm clicking right now on the inspector and I'm not getting any result. But when I go over to the actual game view, it's kind of working the way that I want it to. Okay, so I go from idle to thrust. I'll toggle the play button, and on the thrust state, this is where we're going to do a little physics input here. So I'll go to physics and we'll just add force. And right now I'm going to hardwire the value in along the y-axis, and I'll just estimate this at 20 along the y, and I want to send this not along the world axis. I want to send this along the object's self axis. That way, when we torque this object or rotate it in space, it'll apply the force in the direction of the y-axis, or the up axis of the model itself. So I can test this just to see if I can get it to flying off the ground, and it's not lifting off, and that's because in the thrust state, when we add force right now, I forgot to check every frame. So I'll make sure that for every frame that we're in the thrust state, it's adding force, and there we go. So I'm able to kind of have this basic mechanic where we can kind of force our rocket to go up. Okay, so that'll get the thrust working. Now I'll mock up really quickly just a torque mechanic to effectively rotate this thing. Whenever we talk about rotating a physics-based object, an object with a rigid body, unless it's set to kinematic, we always want to rotate it with physics forces. So we want to add force or add torque, and we don't want to translate by rotating or moving towards those sorts of things. We always want to add physics forces to get this to move. Again, unless it's a kinematic rigid body, which this is not. So I'm going to do this in a separate state machine, and it's always good practice to name our state machines. So I'm going to call this FSM. This is the thrust FSM, and I'm going to create a new FSM, and I can do that a couple of different ways. I'm just going to click on this drop-down menu that allows me to, one, see what FSM I'm looking at on the selected object, and I'll just add a second FSM to the rocket. So now I got a second state machine here. And this one's going to be a fairly simple state that just kind of causes our rocket to torque left and right based on some user input. And this time around for input, I'm not going to map this directly to keys. What I'm going to do is I'm going to do a get axis. And the axis that I'm going to listen for is the horizontal axis. So that's got to be capitalized and spelled properly in order for that to work. And again, the horizontal axis is whatever the player preferences, the input, the player input is set to in Unity. And again, you can kind of take a look at that by going to Edit, Project Settings, Input, and you can take a look at the input manager and see all the different things that are talking to the horizontal axis here. There's a couple different entries for horizontal, and that first entry looks like it's pointing to the A and the D keys, and that's what we'll use to control this. But it also, the arrow keys, it's using the arrow keys as well, left and right. So I'll jump back into my rocket, and this is going to be, I'm going to call this rocket torque for now, just as a reminder that that's what's happening in this state, because this state's really only going to do one thing. So we're listening to the horizontal axis. That's the A and D key by default, and also the left and right arrow keys. And we got a multiplier here of 1. We'll use this to debug the value. We need to store this in a new variable. So this is a float variable, and we'll call this simply rocket rotation for now. Okay. Even though we're torquing it, we'll call it rocket rotation. I have my debug turned on. That's why I see that little store value under here. So right now it's set to 0. When I hit the play button, again, I'm just capturing the user input left and right. And as I hold down the A key, you can see that value go to -1. As I hold down the D key, it goes to +1. So we're operating on this scale of 1, and that's what this multiplier is here. And we'll find out pretty quickly there's a couple of issues with that when we translate this horizontal input to torque. So I'll do that right now. I'll jump in and just look for the physics tab in the Unity, in the Playmaker Actions menu here, and I'm looking for add torque. Again, it's equivalent of rotation. It's a rotational force, and I want to rotate this. I'm looking back in the z-axis. In fact, if I look at the player here, I want to rotate according to that blue axis, or the z-axis. So I'll go find my z-axis, and I'll use the rocket rotation that we're capturing from the user input and apply that as the torque. So make sure that happens every frame. And so now, if I can kind of just put this rocket up in the air, as I hold down the left or right keys, you can see that it starts to torque and cause that rocket to rotate in the visual space here. So now there's a couple of issues. It's kind of hard to tell in this demo, but when I hold down the D key, so I want to rotate to the right, it actually rotates in the opposite direction, or torques in the opposite direction. That's one thing. The other thing too is that when I try to correct for it and rotate in the opposite direction, it takes a really long time for it to correct. And so the controls are really kind of loose and sloppy right now, and I can correct both of those things by manipulating this multiplier. So the first thing I'm going to do, we can correct the rotation or the torque direction by using a negative value, because whenever you multiply a negative value, we're going to get the inverse of that number, and so that will correct. So now we hold down the right key, we're getting a negative z torque, and we hold down the left, we get a positive z torque, which torques this in the proper direction. But the other thing I'm going to do is I'm going to increase this multiplier so that it doesn't operate on a scale of -1 to +1. I'm going to change this to -10. And what that will do is kind of speed up, a little too fast there, but you can see it kind of speeds up, makes the response a little bit snappier. Okay, now there's a couple of other things that are happening here. First is that it feels a little kind of slippery in terms of the rotation. What I mean by that is once we start to rotate, it kind of continues to tumble. In fact, I'm going to go back to a full screen view here so I can focus on the gameplay for a moment. And if I just kind of tap the right key just for a moment, it continues to rotate. We can correct for that by selecting the player and looking at the rigid body component of this player, or this rocket, and we can increase the angular drag. The angular drag is going to be the amount of friction force, basically, that's on this object, and how quickly it comes to a rest. There's drag, or linear drag, and then there's angular drag, and angular drag is going to be the thing that's kind of causes it, when there's a rotational force applied to it, how quickly it comes to rest. And so I'm going to bump this up to, let's try a 1. And again, you'll just have to tweak and kind of play with these values. But you can see that it's a little bit easier to control now, but it's still not resting as quickly as I'd hoped it would. So I'm going to continue to increase that. I'll try 5 and see if that gets closer to it. That's pretty good. As soon as I take my finger off the A or D key, it kind of comes to rest pretty quickly. So right now I got this kind of basic flight mechanic going, and that's there's a couple of other issues going on here which I'll start to address individually. Just kind of some tweaks to the user experience here, the play control, and that's that right now, if we're kind of crazy with this current little physics setup here, I can cause this to kind of fall into the background. So I can cause it to kind of move back into Z space if we get it to start to rotate, and kind of, especially when we hit that landscape there. My camera's not following it yet, but I can see that it's moving according to all three axes. And I really want to restrict this gameplay just to the Y and to the X axis. And I can do that really easily in the rigid body component of this object, and I can just freeze the Z position of this rocket. And so now the Z won't move. So currently the Z position of the player starts off at, looks like -2 and some change. But now no matter what I do, it should keep it on that Z axis. Although it looks like it's moving on us. Doesn't look like it restricted very well. So that Z position's moving. So I'll take a closer look at that and see what that's about. But that should restrict it. The other thing too is I don't want it to rotate back along the X. So I'm going to freeze the position, or excuse me, the rotation along X. And actually, it's not a big deal if it rotates along Y. It's not really going to change the gameplay. But I could also freeze the rotation as well. But this way we shouldn't get too strange results. So, yeah. The Z position is not freezing. So we'll take a look at that, and I'll try to get to the bottom of that and get back to you as to what the issue is there. But that's the basic setup for a simple kind of thrust mechanic. Now there are some alternatives that we could set up. You know, there's a number of things that we can do. We talked in class a little bit about you know, mocking up something a little bit more like a balloon, so that you push it in a direction up, down, left, and right, rather than rotating it and thrusting it. And that would be a slightly different model, but I'll mock that up in the next presentation. But we'll do that soon. So stay tuned.